Hello everyone, welcome to our channel Acadecia. Myself Ushashree, I am from Andhra Pradesh. I am going to teach you mathematics. Let's start with the first chapter, matrices. So, let's start with the definition. Generally, matrix means a rectangular arrangement of few numbers in columns and rows. Rectangular. So, let us take an example. The numbers which are arranged in rows as well as in columns enclosed by a square bracket is called as a matrix. And the elements or the numbers which are present inside the matrix, these are known as entries of a matrix. Next, order of the matrix. Suppose if we are given a matrix, in order to find the order of the matrix, what we have to do? Suppose they have given a matrix called in this matrix, if you want to find the order of the matrix, so how many rows are there? 3. As well as how many columns are there? 3. Simply, order of the matrix is nothing but number of rows into number of columns. So for a given matrix A, what will be the order? Number of rows into number of columns. Next, moving on to the types of matrices. There are so many types, so let us check on each. Row matrix, column matrix, singleton matrix, null or a zero matrix, rectangular matrix, and square matrix. So, these are few types of matrices and let's check on each. In row matrix, we have only one row but n columns. Suppose an example, if you check out this, it has only one row but 4 columns. Okay. Moving on to the next column matrix. It has one column but n rows. For an example, it has one column but n rows. Moving on to the singleton matrix. It has only one column, one row. That means only single element. Take an example. A single column, single row will be there. That is known as a singleton matrix. Null or zero matrix. It can contain m rows and columns as well. But the thing is, every element must be zeros. If you take an example over here, it's like it has n rows and n columns, but every element, it should be equal to 0. Moving on to the next rectangular matrix. Here, number of rows must not be equal to number of columns. Example of rectangular matrix. Here, number of rows are not equal to number of columns. That's why it's known as a rectangular matrix. Suppose if we observe a rectangle, it's like opposite sides are only equal rather than the four sides. It means that only opposite sides will be equal. That means the order will not be same. Okay? Moving on to the square matrix. Number of rows equal to number of columns. If you observe a square, it's like all sides are equal. Same as here in square matrix, all the sides, I mean matrices. So all the sides, I mean number of rows and number of columns will be equal. Start diagonal matrix. Few matrices, I mean diagonal matrix, identity matrix and a scalar matrix. These three are of same type, similarly. So let's see. Scalar matrix, identity matrix. So these three matrices are quite similar. I mean elements outside the principal diagonal, elements inside the principal diagonal. So elements outside the principal diagonal must be equals to 0. And the element inside the principal diagonal may or may not be equal to zeros. If you see an example, these are the positions of principal diagonal elements. Remaining positions must be filled with zeros and the principal diagonal positions may or may not be filled with zeros. I mean zeros can involve or may not involve. That's the meaning of diagonal matrix. Coming to the scalar matrix, elements outside the principal diagonal must be equal to zeros, whereas elements inside the principal diagonal must be equal. Whatever the number may be, but it should be equal. For an example, in principal diagonal, the numbers must be equal, whatever the number may be. Suppose, even it's a positive number or a negative number, those must be equal. Coming to the identity matrix, elements outside the principal diagonal must be equals to zeros, whereas inside the principal diagonal must be equal to ones. For an example, other than the principal diagonal, everything must be covered with zeros and the principal diagonal must be covered with only ones. So moving on to the next, triangular matrix. In triangular matrix, there are two types: upper triangular matrix and lower triangular matrix. Upper triangular matrix. Let us take an example. And for the lower triangular matrix as well. Here, what we observe, the zeros which are there, it's forming a triangle, as well as here too. Okay, so the numbers or the elements which are present in a matrix, that must be in an upper triangle, such that is known as an upper triangular matrix. And in the lower triangle, it must be filled with only zeros. Here, in the upper triangle, it must be filled with only zeros. And the remaining numbers which are there, those are present in the lower triangle. That's why we have named this as upper triangle and this as a lower triangle matrix.